Hello, friends. Welcome to another episode of this simulation series. And this is, I guess, the fifth episode of the series. And in this episode, we are trying to see how to simulate triangular distribution and exponential distribution, of course, using Excel. So, earlier in the first episode, and also during the course itself, we have seen that these distributions have their own inverse function defined in Excel. That means if you use these inverse functions in Excel, you can simulate them easily. But unfortunately, two types of distributions are missing here: triangular distribution and the exponential distribution. So therefore, it is not possible to use any Excel native function to directly simulate these two distributions. So therefore, we have to learn how to implement certain fundamental calculations in Excel in order to implement the inverse functionality. So first of all, the exponential distributions. So in this case, we have two methods. As you can see here, method 1 and method 2. Method 1 is simply using the cumulative distribution functions, that is CDF of the exponential distribution, and from that we will find the inverse function. And second method is using gamma distribution. So let us first try to understand the first method. In this case, see, this is the definition of the cumulative distribution function for exponential distribution. So if you can see, fx is the cumulative distribution, that is equal to 1 minus exponential of minus lambda into x. And what is lambda? Lambda is the arrival rate. So something is arriving, the rate at which it is arriving is the arrival rate. So that is the only one parameter of this exponential distribution, and that is lambda. Okay. So now if you just try to rewrite this equation and take this e to the power minus lambda into x to the left side, then in the right side you get 1 minus fx. Then you take ln. Ln means natural log to both sides. That means take natural log of left hand side and right hand side. So this exponential of minus lambda x comes as a coefficient, and then ln of e, and then in the right hand side is ln of 1 minus fx. So as you can see, or you may already know, that ln of e is always equal to 1. So this is 1. So that means you can write x as ln into 1 minus fx divided by minus lambda. Okay, so this is the final expression. We will use this particular expression to find the value of x given the value of fx. Now remember, what is fx? If you can remember, in our all simulation exercise, fx is always our random number. That means Rn. That means using the rand function in Excel, we'll have a value of fx, and based on that we will calculate the value of x, which is the random variate. This is the random variate. The definition of random variate: random number, fx, all these things have been discussed in the first episode of this series. So if you have not watched that video, please go and watch that video, and then come back here again. So this is the first method. What is the second method? Second method is using the gamma distribution. Always remember that gamma distribution is a special case of exponential distribution. Gamma distribution has two parameters, alpha and beta. So when alpha is equal to 1 and beta is equal to 1 minus lambda, then the distribution, this type of distribution, gamma distribution, reduces to exponential distribution. with mean is equal to lambda. So fortunately, Excel has given us the gamma inverse function. It has not given us exponential inverse function, but gamma inverse function is available. So using that gamma inverse function, if you just enter alpha is equal to 1 and beta is equal to 1 minus lambda, then and again fx is what is fx? Fx is random number. That means this rand. If you enter this, then you get x from here using this formula, and that is your random variate following that exponential distribution. So these are the two methods we need to follow. So that is all about exponential distribution. So let us understand the triangular distribution. In case of triangular distribution, suppose the random variate x is following triangular distribution, and then it will have three parameters: a, b, and c. A is the pessimistic value, C is the most likely value, and B is the optimistic value. And by pessimistic and optimistic, I mean A will be always less than B, right? So, for example, in case of profit or sales, suppose some pessimistic value is given and some optimistic value is given. So, always assign A as the lower value, and C is obviously lying between A and B, and hence it is the most likely value. So the distribution looks something like this. Here is the A, this is C, and this is B. And this particular probability is C minus A divided by B minus A. How to derive these things, I am not discussing it here. And this particular function, that means triangular distribution, also had its PDF and CDF, and using those formulations we can derive these two relationships. So that means if fx, that is the CDF, this is the CDF, is less than or equal to C minus A divided by B minus A, that means this particular value. So that means if fx is within this, I mean not greater than this value, then the random variate, this is the random variate again, can be calculated using this particular expression where fx is always your random number, that is rand parenthesis. And then if fx is not less than equal to C minus A by B minus A, that means greater than that, then your x takes this value. So it may be a little confusing from where this formula are coming. So if that is the case, you can read the texts related to triangular distribution. I am not just discussing it anyhow here, because there will be an expression for fx involving x. So it has just transformed fx. It is like in this form: fx is a function of fx like this, and then it has taken the inverse. That means x is in terms of fx. I hope this is clear. X expressed in terms of fx. So that much calculation they have done, and these two formula we have to readily use, so we can do that. So that's all about the theory part. Let us come to the Excel sheet and try to implement these two inverse functions, that means exponential and triangular distribution. So suppose we have an exponential distribution having lambda is equal to 2. That means the mean arrival rate, this is the mean arrival rate, that is 2, something like 2 customers per hour or anything like that. And then we have a series of random numbers. We'll just then generate this using the rand function, right? So suppose these many are here. Then we will find the inverse exponential variable, that means our random variate, using both our methods. So what was our first method? That is the fundamental CDF using your exponential CDF. That means x is equal to what? Ln of 1 minus fx, right? Divided by minus lambda. This was already mentioned in the slide. So now I am trying to implement this in Excel. So ln of 1 minus fx. What is fx? We all know fx is nothing but our random number. So this is Rn. So we have our Rn here. So just enter this, then divide by minus lambda, minus lambda. So this is the complete formula. So these are the random variates we calculated for this particular exponential distribution with a mean equal to 2, mean arrival rate. Now for method 2, we need to use the gamma distribution. So gamma inverse, this is your gamma inverse function. Then probability, in case of probability, this is basically fx. So we will write the random number in place of fx. Then I told you what is the alpha and beta. So in this particular case, alpha is equal to 1 and beta is equal to 1 minus lambda, right? So write that here, alpha is 1 and beta is 1 minus 1 divided by lambda. Okay, so see, these two are exactly matching. So both method 1 and method 2 are giving you the same solutions for these random numbers. Of course, if you press F9 in your keyboard, then these random numbers will change, and according to that, the output of the inverse functions will also change. But in any case, these two will match. So that is one thing related to exponential distribution. Now let us come to the triangular distributions. Before implementing anything, let me write this formula. So when fx is less than or equal to c minus a divided by b minus a, we have our expression as x is equal to a plus under square root fx into b minus a into c minus a, right? This was the thing written here. You can check. I'm just writing it here because otherwise it is difficult to write formula directly. And then if fx is greater than this item, then the expression of x is equal to b minus under square root 1 minus fx into again b minus a into c minus a, right? So suppose there is a company and a product. There are three estimates of the unit price, selling price. One is your pessimistic estimate, something 18.95. See the worst case. This is the worst case, and this is the best case, best estimate or optimistic estimate, and this is the most likely. That means mean. So then let us implement this. So first off, we will write this down. So first of all, what is c minus a divided by b minus a? We don't want to write clumsy formula here because we can write all these things in one single if function, but that will be too clumsy and difficult for you to understand. So I will break it down and then use the final if function. So this is c minus a divided by b minus a. Okay, so we have written this one. We will also write this one. So b minus a into c minus a. So b minus a into c minus a. Now what? Now this is the random variate. How to write that? Or even before that, you can use the random number. So this is your random number. What is that? That is your fx, right? We will need to write fx also here. So now use if function. If my fx is less than or equal to this, right? Less than or equal to c minus a by b minus a, which is this. Then what is the x value? X value is a plus this. So a plus square root of fx into this one, right? And if not, that means if fx is not less than equal to c minus a by b minus a, that means it is greater than that. Then what is x? X is equal to b minus square root of 1 minus fx. That means 1 minus this random number into b minus a into c minus a. That means this one, this. So this completes the formulation, and here is the output. So using this triangular distribution, the unit price of a random variate is 20.28 for just one replication. If you can remember that we are taking an uh, advanced approach of simulating every case, like for the left hand side of our worksheet, we are just developing the model just for one replication, and then using data table here, which I'm not going to do in this video. We have already discussed these things, how to conduct data table analysis, and using data table developing the simulation output. So that is the second part, which we are not discussing here. We are just, our topic of discussion is confined to getting the inverse function of exponential distribution and triangular distribution in this video. So for the first replication, you have got your random variate, and now using data table you can simulate this random variate as many times as you want. So that's it for this video. That means we have learned that how to generate inverse functions for exponential distribution and triangular distribution. For the inverse functions were directly not given in Excel's native functionality, and maybe using some other software or maybe other packages which is installed on Excel, you can probably find exponential inverse function or triangular inverse functions, but not using Excel's native functionality. So these are the tricks of using Excel and without any software or any other add-ins simulating the triangular distribution and exponential distribution. So hope you have understood the content of the video. If not, then watch it again and practice it. Practice the content of this worksheet and these two calculations, and get confidence. That's it about this video. Let us meet in the next video. And to me, this is the end of the simulation series, because I don't have anything else to teach here. Unless you have any specific query regarding simulation or any doubt, then please use the comment section to inform me. Based on that, I will try to make other videos. But until then, this is the final video, and hope you have understood the simulation series, and please give me feedback. Thank you for listening.